All right, so the variance of the portfolio is going to be the weighted sum of the covariance of returns on each pair of assets. And we are going to get into that. I just wanted to walk you through like the logic and the words. Let me just give you some intuition. So when we talk about the variance of the portfolio, let's pretend that we invested in a certain amount of each of these. The amount of ups and downs that we have is going to be based on how volatile this is, etc., all of these. But it's also going to depend on how they move together. So let's pretend in this case that we only invested in these two. If they're completely uncorrelated, then all we care about is the difference, is the different volatility in each of these times the weight that we put on it. So let's say that we're super risk averse and we want 80% of our portfolio in the supermarket and 20% in the internet startup. Well, since they're not correlated at all, the correlation is zero, then this will be its own risk and this will be its own risk. And because this is a larger part of the portfolio but a lower portion of risk, then the total risk that we face is going to be lower. But if these are correlated, let's say we have a good year and this does well, this also does well, the total risk of the portfolio will be a function of both of these together and their individual risks. And so for a portfolio with the 4 assets, you have to do every single pair combination of variances in order to figure out exactly what the risk is for the portfolio. We'll do that in a second. I just wanted to introduce it to you. Okay, so this is the example that we're going to start with. We are going to have 3 different states of the world, and again, this is super arbitrary. Like, imagine how many different, if you were to roll a dice on the pair of dice on the U.S. economy, you think that there's 6 states of the world, or 12, or however many possible combinations there are? No, there's millions of possible ways that the economy could be functioning in a year from now. But for our purposes, we're going to assess like a certain probability to each of these returns. And what it usually ends up as, like, if you work in a consulting environment or whatever, a lot of times it's easy to say, well, if good things happen, and there's a 20% chance that this happens, then these are our outcomes. In sort of everything continues state of the world, 50% of the time we end up with these returns. If things get really bad, 30% of the time we end up with these returns. It's a way of capturing the potential outcomes in very simple, easy to understand terms. Is it realistic? Not on your life. But it gives us an idea of what the returns would be if those states were realized. So the example that's in Professor Hall's slides, he has 3 different stocks, CVS, Microsoft, and Chevron. We have expected returns. The way that you would kind of end up with these numbers is you would conduct some internal projection, and you would say, let me take CVS's balance sheet or their cash flow statement or both, and look at that and say, well, if things are bad, then what would the possible return be? Same with Microsoft, same with Chevron. And the idea here is there are different analysts who follow each of these. They have different forecasts for the outcome. I want to make a portfolio. There's a probability of each outcome of that amount, and therefore this is what's going to be in the portfolio. So before I get into that, let me just show you a preview of what's going to happen. Here is the expected return of each of these assets and the standard deviation. So this is like the canonical plot of every single sort of asset pricing. When you picture this in your mind, I want you to picture this. The idea is that each of these 3 assets are kind of dots. The size of the bubble has to do with market cap. But in general, the idea is that Microsoft has a little bit more risk. The standard deviation is higher, 26%. But the expected return is 12.3%. And here we have CVS, 12.6, 10.35, etc. When we form a portfolio, I believe we're going to use CVS and Microsoft, we end up with a lower level of risk, but about the same return as we had with the 2 assets. And if you look at this, this is a plot. So Professor Hall did this. This is a plot of all possible portfolios, and he chooses 18 different portfolios with different weights. And so each of these dots is a different portfolio. And so as you go down the line here, you lower your risk and you increase your expected return given that risk. So the idea is, I'm not sure what weight I should put on these different stocks. I have these different probabilities of the world. I know that if I form a portfolio with them, that there are a bunch of different options. I run all of these numbers through my fancy smancy spreadsheet, and then I pick a portfolio that lowers my risk to a point where I'm comfortable with it. Yeah, so I'm not going to pay attention to that right now. And let me just finish this, and then we'll do the actual numerical example in the next lecture. So the idea is that if we calculate these weights, we can optimize our portfolio choices. So we calculate weights for, and it could be millions of portfolios. And if we know the weights of the different assets in these portfolios, and we know the potential outcome, the probability, we know the standard deviation, we know the risk, then we can optimize our choices. The problem is, with thousands of possible assets, this becomes incredibly intractable. Like, there's not enough atoms in the universe to run the calculation on a computer that we know. However, one can do this with a small number of assets, and there's lots of ways that asset pricers and people in finance sort of get back of the envelope ideas about what to invest in. And literally all of asset pricing research, like the entire history of asset pricing research, is about how to pick the optimal portfolio, how to find a stock that has some characteristics that is above and beyond what the stock had, what the individual stock would have told us or something like that. And Excel can provide us some rough approximations for these things. I want to show you this formula. I don't think that you should necessarily memorize this, but this is the mathematical way of denoting what we're about to do. So when we talk about mu A, mu B, mu C, mu is always like the expected return. We have some weight, WA times mu A, so the expected return on the portfolio is the weight times the mean. And then we have this giant, scary formula that has the covariance and the variance. You do not need to memorize this formula. If you watch the next video where I go over the setup of the Excel file, you are going to be just fine. But I want you to see it so that if you ever move on and decide to do this as a career, that you don't freak out about this formula. All it is the weight of asset A times the weight of asset A times the covariance of asset A with asset A, which is also the variance. It looks really scary. It's not. If you want to learn more about it, just email me and I'll teach you whatever you want to know. Okay, last thing before we start on the description. We have the variance, covariance, standard deviation. Oh, I already put covariance in. And correlation, and that helps us describe how two assets or any n number of assets move in relation to each other. And doing these calculations on large portfolios is it's really difficult the larger the number of assets gets. But for 2 or 3 assets, to show you like an idea of how it works is not very hard at all. In fact, we're going to do that next. And finally, when you do the variance and covariance matrices, it's really scary because you see all these numbers and it's hard to understand what they mean. It's not that bad. Matrix algebra is used in a lot of these applications. So quant funds will usually express things in matrix notation. It's just an easier way of writing down a bunch of formulas. So this formula itself can be written in like 3 words or 3 letters in matrix notation, whereas here it's this huge formula. So what I want you to take away from this is that we are going to do an Excel calculation using 3 assets, and we're going to make a portfolio based on those. And it's going to take you about 45 minutes to work through the whole thing on your own, but it's really not that bad.